Good day, mathematicians. I am Mark Rallion Biganara, and I am tasked to answer the exercise 2.2, number 43. Exercise 43 to 46, use the given definition to find f of a. If f is a polynomial function, f of x is equal to a sub 0 plus a sub 1x plus a sub 2x squared to a sub n x raised to n. Then, for n by n matrix A, f of A is defined to be f of A is equal to a sub 0 I sub n plus a sub 1 a plus a sub 2 a squared to a sub n a raised to n, where the function of x is equal to x squared minus 5x plus 2 and a is equal to 2 by 2 matrix 2, 0, 4, 5. To answer this problem, the first thing you need to do is to substitute all the x into a, so we have a squared minus 5a plus 2. After that, same rule in function, substitute all the a with the given 2 by 2 matrix, so we have 2 by 2 matrix 2045 squared minus 5 times matrix A plus 2. As you can see, the problem here is that there is a single number, which is the 2. And you can't add a matrix to a single digit because this is not defined. So, we should make that 2 into 2 by 2 matrix. So what are we going to do to fix this problem? As you go back to the equation, you can see 2, or not just 2, but it is 2 times 1. So let's think on a real analog of 1 into the real matrices. Well, there is a special matrix that plays the role of the real number 1, and that is of course the identity matrix. So once we jump over matrices, 1 becomes I, and I will inherit the size of the matrix A. Since A here is 2 by 2, I will also be 2 by 2. Therefore, we have a 2 by 2 matrix 1, 0, 0, 1. So now we solve the first problem, and we can now compute the final answer. The next thing you need to do is to perform the given operation in each matrix. A squared is equal to matrix 2045 times 2 itself. Then, next is 5 times the matrix A. The rule in this operation is to multiply the constant to each number inside the matrix. So, the result will be 10, 0, 20, 25. Same rule, we just need to multiply the constant in the matrix. So we get 2, 0, 0, 2. Before we add the two matrices, let's compute first the a squared. In this operation, the first thing we need to do is to take the numbers in the first row of the matrix and then multiply it by the numbers of the first column. We are going to multiply 2 by 2 and 0 by 4. So we can get a 4. Next is to take the numbers in the first row and multiply it by the numbers in column 2. So we are going to multiply 2 into 0 and 0 into 5. And we get a result of 0. Next, get the number in row 2 and multiply it with column 1. So, 4 multiplied by 2 and 5 is multiplied by 4. And we have a result of 28. And lastly, we take the numbers in row 2 and multiply it by column 2. So we have 4 multiplied by 0 and 5 multiplied by 5, and we have a result of 25. Now we have new matrix 4, 0, 28, and 25. We can now do the addition in the equation. So, in this operation, the rule is that we need to add the corresponding elements. The first thing we need to do is to get the number in row 1 and add it with column 1. So, it's gonna be negative 10 plus 2 and we get negative 8. And 0 plus 0 is equal to 0. Next, we need to get the number in row 2 and add it with column 2. So, we have negative 20 plus 0 is equal to negative 20, and we have negative 25 plus 2 and we get negative 23. So now, we have a new matrix 8, 0, 20, and 23. We can now do the final operation, which is to subtract the two matrices. In this operation, the rule is same with addition. We need to subtract the corresponding elements. So, we take the number in row 1 and subtract it with column 1. We have 4 minus 8 is equal to negative 4 and 0 minus 0 is 0. Next, get the numbers in row 2 and subtract it with column 2. So we have 28 minus 20 is equal to 8 and 25 minus 23 is equal to 2. And now we are able to do all the operation and get the final answer. The final answer is a matrix negative 4, 0, 8, 2.